Now we need to look at uncertainty and errors in measurement. We have to describe and give examples of random and systematic errors. So if we get a spread of values, we can reduce this random error by taking more values and then finding an average. So we basically find out what is the average value, and if it's accurate, then we should get the real value. This is a random error. This is where the values are spread around an average point. If we have a large random error, the device that we're using is not very precise. If we have a very small random error, if all the points are very close together, we have a very precise instrument. On the other hand, we have what's called a systematic error. This is an error which is inherent in the method of collection, and you can detect it by using different equipment or by using a different method. This example of using the laser, if the laser was pointing at a target and yet was consistently 4 inches to the left of the target, we could say that it was precise because all the points were very close together, but it's not accurate. It's not accurate, and therefore it has a systematic error. It means that some device, some part of the laser always made it shoot 4 inches to the left. So this is a systematic error. And as I say, if we have a large systematic error, it means it's not very accurate. Let's look at these. Somebody's throwing some darts at a dartboard, and we have to decide, differentiate between precision and accuracy. Now, number one, all the points are fairly close together, but they're not very close to the target. So it's not very accurate. However, it is precise. So there's a small random error, but there's a systematic error which is quite large. So this is precise, not very accurate. Number two, this is not very precise because the darts are fairly well spread out. However, if you took an average, you're going to end up with more or less where the bullseye is. So it's actually quite accurate, but it's not very precise. The third one, this is not very precise because all the points are spread out, some kind of a very large random error. Also, they all seem to be high to the left, so there's a systematic error as well. So it's not precise and it's not accurate. This one, however, is precise because all the arrows basically hit the same point, and it also is very close to the target, so it's both precise and accurate. So there's no systematic error and there's very small random error. Here we have a graph which shows this. If this is a true value and these are the number of readings, we find out all these readings are very close together, but they're not near true value. So it's precise but not accurate. This one, the average is fairly close to the true value, so we can say it's fairly accurate but not very precise because the values are spread out over a large area. Here again, this is a value. The values are fairly well spread out, which means it's not very precise and it's not very accurate either. Now the true value is here, so this is fairly precise because all the points are very close together, but it's also quite accurate as well.